So the next presentation is by Charlie Roberts from the Worcester Polytechnic Institute and Mariana Pachón-Puentes, also from Worcester. The presentation title is Bringing the TidalCycles mini language to the web. And perhaps Charlie could maybe answer the question why we need another live coding language.
Yeah, so as I don't know if I'm going to answer that question specifically. I'm here to talk about a really targeted research project done by myself and Mariana, and it's bringing the TidalCycles mini annotation to the browser. And again, this is a pretty small project, but it's been fun to play around with, and I think hopefully this is the right target audience for people that might be interested in using it and experimenting with it themselves. So this talk, I'll basically just briefly mention what TidalCycles is, what live coding is, and what is the TidalCycles mini annotation, talk about how we implemented this, and show a few different examples of it in use. So Jesse mentioned earlier that network music performance has been a big focus of the Web Audio Conference, and I think live coding performance has also been another kind of focus area that we've seen a lot of in the past years. And so I know we already just saw a paper now. I know there's a couple more papers coming in the conferences, and there's at least 3 performances in the different concerts that are going to incorporate live coding in some form or another. So I think a lot of us are familiar with it, but the basic idea is you get up on stage and you write some code, and beautiful music and visuals come out, and everybody is happy. So this is a specific, this picture that we're looking at right here is a specific genre of live coding performance called an Algorave. Algorave was held at the British Library earlier this year. And in an Algorave, there's all sorts of types of music that is created during live coding performances. But in Algoraves, typically the music is more informed by dance music than in some other genres that you might think of. So this year was the 5th anniversary of Algoraves, and as part of that 5th anniversary, there was an organized 4-day streaming event where there were 160 performances over 4 days that were streamed all around the world. And so as one measure of the TidalCycles popularity, I looked at all those performances and noted that 65 of the performances used TidalCycles as the main front-end language for music generation. So at least in the Algorave genre of performance, TidalCycles really has kind of become this sort of dominant language. The next closest was SuperCollider with 18 performances. And this is, again, talking about the front-end language that people are actually live coding inside of. So what is it that makes TidalCycles interesting? So if you've never used TidalCycles before, this is a language created by Alex McLean and first presented in 2010. It is built in Haskell, and you can code and target it using lots of different coding environments can take advantage of TidalCycles. It outputs OSC and MIDI messages, so it doesn't actually create sound itself or create visuals itself. It's used as an external control language for sequencing patterns over time to target these applications. And one thing I did want to also point out is that it actually is already in the browser via David Ogborn's Estuary project. And what David Ogborn did in that is he used the new Haskell compiler to compile the entire system into JavaScript and then placed it online, which is great. What I'm going to be presenting and talking about today is a little bit different, and we're trying to make just a dedicated, targeted library for JavaScript, no Haskell compilation required to use this system. Okay, so let me just show TidalCycles in action running inside of Gibber to kind of get an idea of what it's capable of doing. And one of the big differences, and one of my motivations for incorporating this into Gibber, which is a live coding system that I work on, is thinking about timing and output in the space of a single notation. So in Gibber, normally you make a synth, And then you say things like, oh, I want a sequence that's synth, and you define a bunch of different notes that you want to play, and then you define some different rhythms that you want to play. And so you have this separation between the output values for the sequence and the timing values for the sequence. There are two different separate patterns that you can manipulate in different ways and independently of one another. Whereas TidalCycles has a unified pattern syntax for defining both the output and the timing at the same time, similar in some ways to what we saw in the last presentation with Quaver series. And I thought that combining those things provides some different opportunities for sequencing that Gibber didn't currently provide, and I wanted to explore that a little bit more. So let's, I'm gonna just download a sample. And if I trigger it now, this just means play it at the original rate it was recorded at. Okay, so there's the almond break, and I can play it back at different speeds and whatever. So to use the title cycling inside of Gibber, you just take any method or property of any audiovisual object and add .title to it, and then you can create sequences that control that method or that property over time. So title cycle, like Quaver series that was just discussed, it kind of looks at the number of tokens inside of the sequence and counts them and uses that to determine how much time each token in that sequence is going to occupy. And so in the length of the sequence is called a cycle that we're using. So right now I have one entity in the pattern, and it's going to occupy one cycle. And so if I start that playing, so every time you see the square flash, it's kind of re-triggering that pattern. And as I add more patterns, or more to this, so now it's moving through all the different values that you see inside of there. And so as I add more values, obviously it gets faster and faster and increases in tempo. We can also group the different values together. So using the bracket notations, basically this is now grouped to be considered one entity, so each one of these will take a third, and then each one of these two will take a sixth. And you can also do things like specify, oh, I want to play a whole bunch of these really fast. So now we have 8 triggers playing at the original sampling rate, and then one trigger playing at twice the speed. And again, the important thing is that each of these two components occupies the same amount of time. So you can think about each entity in the pattern individually and start a different way to conceptualize time and creating these different types of patterns together. So to create this inside of the browser, we created a parser using the parsing expression grammar formalism, PEG.js, parsing expression grammars. It's a language formalism that's present in almost every scripting programming language you can create using these ideas. And basically, you define your pattern, you submit it to a pattern object that you can that parses the pattern, and then you can query the resulting pattern objects to get a list of events that you want to use. And that just comes back to you in the form of an array. And so the query, basically, you specify the starting phase for when you want to query, and then you specify how long you want to query. The length is in terms of cycles. So for this particular pattern, we're querying one cycle of the pattern starting with a phase of 0, and it's giving back these events. Each event has a value associated with it, so one of these 3 numbers, and it has an arc which defines the starting point for the event and the ending point of the event. These are all measured in rational time values. And then once you have this list of events, it's basically up to you to do some type of sequencing thing that loops through these events, figures out which one of these should play, and applies the pattern accordingly. So I wanted to show a quick example of applying this to Olivia Jack's amazing Hydra live coding environments. This is a live coding system for creating visuals based on the metaphor of analog video synthesizers. And so there's a GitHub gist. I'm just going to copy all it. Maybe I'll walk through it really quickly to explain it before I copy and paste it in. So the first thing I'm going to do is I'm just going to inject the code for the pattern library that I've created. And then we have this function I've defined that's just called title. And it's going to create a pattern object similar to the slide I just showed, where you pass in a pattern, it makes that object, and it's going to generate an out function that's going to increment a phase. It's going to check and see if there are any events in a queue, and if there are not, it is going to do a new query to generate a new set of events, and then once the events have been queued up, it checks to see if the next event that's supposed to be played, basically event 0, if the current phase is greater than the phase associated with that particular event, then we know we want to trigger that particular event and return the value. So this whole thing here is about 30 lines of code. It doesn't take much to once you have the pattern parsing and the querying capability to stick this into a system and be able to use it. Okay, so I'll run that huge thing. Oh, Charlie, bad demo. Okay, so I lost the code that. Okay. This is what I wanted. Not that. Not that. Okay. Okay. So what this is doing right here is it's making an oscillator, and then we have that title function that we just looked at the code for. That title function itself returns another function, and that's the function that's keeping track of the phase and doing the querying of the pattern. In Hydra, whenever you have a function that's passed to one of the synthesis objects, it calls that function once per frame to generate a value, and that's what gets used for the visual synthesis. So right here we have this, this is basically controlling the frequency of the oscillator, so the number of bands that you're seeing right here. So in this first part, it's alternating between values of 1 and 20 every other cycle, and then it's looping back and forth between 50 and 100, and I can jump back in and make that faster or change these different values and re-execute it in different ways. So just a really quick sample of trying to show that it's easy to integrate with other systems and hopefully into your own JavaScript projects if you're interested in taking a look at this. Another interesting project that's already used this library is Diego Dorado's live emojiing system. If some of you were at ICLC this year, you might have seen this in use. And so the way live emojiing works is it takes each one of these emojis and it maps a sample to it. And then you can use the title mini notation. It's all browser-based, and create these pretty cool animated sequences of emojis that flash on the screens with associated sounds that trigger along with them. The library itself, the GitHub repo comes with a bunch of different demos, just regular, simple, bare bones HTML demos. Also integration with P5 is another demo that's inside of there, and hopefully enough to get people started using it really quickly. I don't think I'm gonna have enough time to talk about this, but in addition, I guess I'll just mention inside of Gibber, it also integrates with the visual engine in addition to the audio engine. And I did also, I guess I will really briefly point out just the highlighting here, just to kind of make things easy to understand what's happening inside of the patterns. So just giving that little flash to kind of show which one of these is actually being triggered at a time. And the idea is that as the patterns get more and more complicated, it can start to help people, whether audience members or programmers who are actually creating patterns, actually understand how the mini notation works and how all these different notation features fit together. So I'll be performing with that later tonight, and we'll get to see it in action. For now, thanks, and I'll take any questions.
Brilliant. Thank you, Charlie. So we have a question over there.
Thanks for the great presentation. I'm just curious, is the title function in Hydra, like, did you make a pull request or that was there before? Or?
No, I just had to copy and paste the code in and write. So no, it's not in Hydra now. I didn't think about making a pull request to Olivia, but it is also it's simpler than I made it look like to just copy and paste it in there and run it.
So you can basically like run JavaScript, because I've used Hydra, but like, can you just like import JavaScript in Hydra and then use it? Was that what happened?
Yeah, you can just, I mean, it's JavaScript, so you can do anything you want, basically. I mean, so if the code in that gets basically makes a new script tag, and then it sets the source of that script tag to be the title parser, and then it injects that into the head of the HTML document, and so that's how it gets loaded dynamically.
So it's like a hack to Hydra.
Yes, exactly.
Thank you.
Other questions? Well, there's one here.
So you've programmed Gibber, you've programmed in JavaScript, you're now working with TidalCycles. Can you just comment on the difficulty or not of jumping between language to language to language in trying to do live coding? It kind of gets back to that, why do we need another live coding language? But have you found that? How have you found that?
Yeah, I mean, I guess I don't feel like at this point that so I have done performances where I've explicitly been jumping back and forth between languages, JavaScript and GLSL, and that was lame. I'm never doing that again. Yeah, I think there is like a cognitive load that's associated with that, and trying to get things into one language is important to me. I mean, the mini notation with TidalCycles, and maybe I didn't explain enough about what that actually is and compared to the rest of TidalCycles, but it really isn't a language. It's it's just this little notation that then gets chopped up and assigned to different Haskell functions to do things, or in this case, different JavaScript functions to do things. But the idea of bringing the mini notation in there was to try and, yeah, it is a different way of thinking. But I don't know. I don't know if I would classify it as maybe there still is an interesting mind jump that has to happen to go from doing JavaScript into that system. I hadn't thought about it. Is the honest answer to the question.
Well, I could follow up with the final question, maybe. So you implemented Tidal as a function of Gibber, but is it the whole of Tidal language? Or?
No, yeah, so that's definitely future work is to think about. So this is just the interface for defining the patterns, and of course the really important part of live coding is transforming patterns over time, and Tidal has a lot of really amazing capabilities in that regards. And so one of the things I'm struggling with right now is to think about whether or not I want to use Gibber's existing pattern transformation capabilities and apply those to the Tidal functions, or do I really want to bring in all of the Tidal transformation functions inside of there, and at what point is it Tidal versus what point is it Gibber then, and lots of other interesting questions. But I think for now there are enough times when I want to use the Gibber notation as opposed to the Tidal notation that I'd like to keep maintaining kind of both systems, and maybe add an ICSI one to it as well. I think just having lots of different notations to describe patterns can be useful for different people in different applications.
From the short example you showed, it looked a little bit like you were taking the ideas of Tidal but putting it into the kind of type of JavaScript that you use in Gibber. Is that correct? Or? Because it didn't look like Tidal, it looked like Gibber.
It's just the little mini, so just the part, again, I didn't explain this part well enough, but just the thing in the quotes.
Yeah.
So just this part is the only thing I'm taking. Maybe that's not a very good example. I'll make it a little more Tidal-y looking. So just this part in between the quotes is what I'm taking from Tidal. And in TidalCycles, when you use it as well, it's also just provided in quotes. So it's a mini notation that's provided inside of the TidalCycles mini language to compose functions more rapidly than having to explicitly type them all out by hand.
That's fantastic. It's like a little slang dialect within Gibber then.
Yeah,
you know, so.
yeah.